8.4 combinations. So the difference between a permutation and a combination is a combination doesn't actually matter what order you pick the things in, as long as they've been picked. So an example would be if you're putting people into a group, it doesn't matter if I pick person 1, then person 2, or person 2, then person 1. As long as you've both been put into that group, that's all that matters. So in the Keno lottery, 20 numbers from 1 to 80 are chosen. How many combinations of 20 numbers are possible? It doesn't matter what order they get drawn in, it just matters that it was drawn. So we would do 80, and we're going to do choose 20. So another way to write it is 80 over 20. I don't know how often that will look like that. But here's our formula. So it's the same as a permutation, except there's an extra r factorial in front. So it would be 80 factorial divided by 20 factorial times 80 minus 60 factorial. And honestly, that's too much work. So just type in 80 choose 20. And it's a really big number. It's 3.53531614 times 10 to the power of 18. So there should be a C button on your calculator as well as that pick button. Okay, a local arena has applicants interested in working in the snack bar. How many ways can 4 applicants be chosen? So we have 10, and we're choosing 4 of them. So it'd be 10 factorial over 4 factorial, 10 minus 4 factorial. This one we could simplify. So we have 10 factorial over 4 factorial, 6 factorial. I'd want to rewrite this all the way down to 6 factorial. And then I have 4 times 3 times 2 times 1. The 6 factorials cancel. I could say that 10 divided by 2 is 5, 9 divided by 3 is 3, 8 divided by 4 is 2. So we have 5 times 3 times 2 times 7, and we would get 210. How many ways can 6 be chosen? So I would do 10 choose 6. So it would be 10 factorial divided by 6 factorial, 10 minus 4 6 factorial, getting ahead of myself, is equal to 10 factorial over 6 factorial, 4 factorial. And what you should notice is this is the same as this. So it's going to also be 10. So choosing 6 people is no different than choosing 10 people. So thinking about this, if I have 10 and I'm choosing 0 things, there's one way that that can happen, and that's by picking none of them. If I have 10 and I'm choosing 10 things, just kidding, one thing, there's 10 ways I can do that. Now thinking on the other end, if I have 10 and I'm choosing all 10 things, there's only one way that can happen, and that's by picking everybody. If I have 10 and I'm choosing 9 things, that's also going to be 10, because there's 10 ways to do it where you're leaving one left over, which is the same as this. So if I type in 10 choose 2, I get 45. If I type in 10 choose 3, I get 130. If I type in 10 choose 4, I get 210. If I type in 10 choose 5, I get 252. And what I notice is once I start to get to 10 choose 6, I start repeating myself, so 10 to 10. So I can guess that 10 choose 7 is going to be 130, and I can guess that 10 choose 8 is going to be 45. And this pattern is going to become really useful for us when we do the next lesson. Okay, the admission requirements for a university are as follow. You need an English A or B 30. You need 3 extracurriculars for grade 12. You need English 20. You need 1 of the maths at the 30 level. You need social 20 or native studies 20. You need 5 science courses and 24 language courses. So how many ways can you meet these requirements? So let's do English first. You can have English A or you can have English B. So we have two things and you can choose one of them. So to choose one is 2. We can do our extracurricular. And we have 16 courses and we need 3 of them. So we're going to go 16, choose 3, type that into our calculator, and there's 560. You need English 20. That's just one class. There's one of them and you have to choose that one thing. You need one of these maths. So there's 3 of them and we're choosing one of them. So there's 3 ways to choose a math. You need a social science or a social studies course. So there's 2 of them and we're choosing one of them. You just need one or the other. So that's 2 options. You need one of 5 science courses. So we have 5 courses, we're choosing one of them. So 5 choose 1 is 5. And you need a language course. So 24, and we need one of them. So there's 24 options. To figure out how many ways we can get into university, we're going to multiply all those options together because they're all different instances of things and we need a combination of all of them. So we have 2 times 6, 560 times 1 times 3 times 2 times 5 times 24. There are 806,400 ways you could get into university with your high school requirements. Okay. A new store clerk must hire 3 cashiers and 4 store clerks. There are 7 applicants for cashiers and 8 applicants for store clerks. How many ways can they be hired? So we have 7 applicants for cashiers. They need to hire 3 of them. And there are 8 applicants for store clerks and they're hiring 4 of them. So we're going to multiply these together because they're doing both of those things. So 7 choose 3 is 35. 8 choose 4 is 70. Multiply these together and we get 2,450 ways to hire their employees. Okay, different cases. So this is different situations. I also put out a diagram for decks of cards because sometimes we don't remember that and we use them quite a bit in examples. So how many different 5-card hands contain at most 1 black card can be dealt to one person from a standard deck of cards? So we have one situation where we have 1 black card. We have another situation where we have no black cards. And that's the only situations we have for at most 1 black card. So if these are 2 situations, we're going to add them together. Within the situation, I have a situation where I have 1 black and 4 reds. And I have one where I have 0 blacks and 5 reds. And we're going to multiply these because they're part of the same situation. So in a deck of cards, I have 26 black cards. So I'm going to say 26 and I'm choosing one of them. It does not matter what order they are given as long as they are in your hand. So it is a combination. We also have 26 red cards and we're going to be choosing 4 of them. In this one we'll have 26 and we're choosing 0 and 26 choose 5. So if we type this in, there should be 26 times 14,950 plus 1 times 65,780. So altogether there are 454,480 different hands that you could be dealt. And this is why gambling is so tough, because there's never a game where the odds are in your favor. All right, combinations. Now you know. Bye!